we'll go off script here for a second, but a
Yeah.
question I want to hear from all three of you on this topic of AI versus, physics-driven models and the impact of data. Do you see, we have those ranking done by ECMWF and JCSDA and others on the impact of various types of observations on model skill. Do you see those impact scores or ranking changing between physics and AI models? And do you see, maybe these drives are requirements different than what we thought we need because now the models respond to different observations differently.
Okay, I know we're at a microwave meeting, but
It's
if you
not a
look,
microwave
but
meeting.
no,
You can
okay.
go off.
So if you look at information content, pure information content, right? We know like hyperspectral infrared has more information content than microwave, right? However, you got to remember, but microwaves are useful. I like microwave because it's also great for nowcasting applications. You see rain bands and all that, so that's important too. But remember, rain band, where you have interesting weather and weather that's difficult to model, that data is not used in the model. They run away for it. I don't think they use any surface sensitive microwave radiances now in the model. Over infrared, they don't even look at tropospheric infrared data over land. It's amazing how much data is not being used. So I think the ranking will change because because with AI you're going to be able to maximize the use of the data. So absolutely.
Right. Mark?
So I'm probably not the expert to ask that question, but as a traditional meteorologist, physical models are going to be around. They're not going to be replaced. But I think it really depends on the time scale you're talking about. If you're talking about the next 5 to 7 days, it's going to be very difficult to replace physical models. And then there's AI models that are really rapidly growing and have already shown to outperform certain models beyond the 15-day time frame. So they think of your seasonal to sub-seasonal time range, say from 15 to 45 days. But right now, everything I've seen, and maybe I haven't been looking in the right spot, is physical models, AI models. I want to see a time where the two are fused together somehow. Where especially you go from a few days out to your seasonal, your sub-seasonal time frame where you pretty much have to go all either more of your statistical approach or AI approach. There needs to be some kind of fusing with physics and AI I call it the medium term.
Yeah. Forrest, same question.
I'll answer that question with saying I cannot wait to actually answer that question through the data. I want to go and dig into it. I think we now have community tools that are going to help us answer those questions. And I would bet everybody in this audience is going to agree with me that the answer is going to be condition dependent, right? Those charts that we've seen have historically been full atmosphere, a couple of variables, and we kind of don't really understand how it necessarily applies to impacts or making decisions based on that information. So I cannot wait to use the new ability from toolkits that have been provided by Anemoy, NVIDIA, for example, to really dig into that problem and explore things like overall AIFS performs tremendously. Hurricane intensity, is that something where microwave sounders, the impact is extremely valuable versus some other observation system? And I think that's going to be a tremendous area to explore. I think that's also one of the areas where if we start to look at how the field winds up, where you have industry, public sector, private sector, academia, all working together, that's a huge opportunity for academia to be doing those kinds of observation-based physical process study, really probing and testing in the models and understanding why some of these things are the way they are. And that'll help us then design the experiments and the observation systems that then close the gaps to real-world problems.